This is Geometry Unit 3, Lesson 6 on circles. By definition, a circle is a set of points that are all the same distance from a given point. Now, when you're doing a circle, the given point is actually the center of the circle. So if I draw my point there, that is the center of the circle. Now, if I draw points that are the same distance away from this given point, so say I put one here, I go the same distance on the opposite side, I put the same distance over here, down here, and I keep going and filling in. Every time that I am the same distance away, what am I creating? The more points that I put in, you can see that I am actually creating a circle. Every single point on that circle is the same distance away from the center. If I were to actually draw in a line to show our segment to go from the center to the outside edge anywhere, what have I just drawn? The distance from the given point to any point on the circle actually creates the radius of the circle. You can actually create a radius anywhere in the circle. So that radius can be drawn over here, down here, anywhere you want. So the circle is made up of points that are the same distance away from the center. Now that we know that fact, let's see if we can come up with a formula for the equation of a circle. We know a line is y equals mx plus b. Well, the circle must have its own equation as well. And it does. So we're going to derive the formula. So let the coordinates of the center of a circle be C, H, K. Why they use H, K, I have no idea, but they do. This is H, K. And the radius of the circle be R. So I'm going to draw myself a radius. I'm going to draw it like right there. So I have a point to draw. So that's going to be my radius R. I'm going to make my point that it hits in the circle, I'm just going to call it a generic X, Y. So I know what it is. So my line segment that I just drew, CP, is equal to the radius of the circle. That is the radius R of the circle. So this segment right here, CP, is the radius of the circle. Now, the equation of the circle actually comes from finding the length of the radius. So if I wanted to find the length of CP, I need the distance formula. So because this is a graph, I'm actually going to square this off to make a triangle and then use the Pythagorean Theorem. So I'm going to draw my vertical line like this and my horizontal line like this to make my right angle. Now remember, the horizontal distance here is delta x, and the horizontal distance here is delta y. So using the Pythagorean Theorem, we know to find the radius, because the radius is the hypotenuse, leg squared plus leg squared equals hypotenuse squared. So delta x, quantity squared, plus delta y, quantity squared, is equal to r squared. Because this length is delta x, this length is delta y. All right, now using the actual values, what is the delta x? Well, let's see. Delta x is x and h, so x minus h. And then delta y would be y minus k. And that equals the radius squared. So this is actually the formula for the equation of a circle, when you know the center is hk and the radius is r. So the formula that you need to know, if you have the equation of, you want to write the equation of a circle with center at hk and the radius of r, the formula is x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. All you need to know is the center hk and the radius r, and you can write the equation of a circle. It's like writing the equation of a line. If you know m and b, you can write the equation of the line y equals mx plus b, right? Well, this is the same thing. With a circle, you need to know the center at hk and the radius is r. So, if I asked you to write the equation of the circle having a center of 3, negative 7, and radius of 5, we need to know the center hk and the radius r. So, the center is 3, negative 7, so h would be 3, k would be negative 7, and r would be 5. So take this formula, x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. Plug in h, k, and r, but be very careful of your signs. X minus 3, quantity squared, plus y minus negative 7, quantity squared is equal to 5 squared. Now, what is actually minus 7? It's actually plus 7. So it's y plus 7, quantity squared, is equal to 25. That is the equation of my circle. All you have to do is stop there. X minus 3 quantity squared plus y plus 7 quantity squared equals 25. Now, what do you notice about the equation and the actual center point? What do you notice about the signs? The signs are opposite. Signs of the equation are opposite the signs of the actual coordinates. So, when you are using this equation, you need to be aware of that. So when you're doing that, if you're pulling this out, if you saw this equation, you would have to know that this was actually, the coordinate would be 3, and this one would be -7, because the coordinates are always opposite in the equation. Now, don't let the vocabulary throw you. What is the equation of the locus of points that are 8 units from the point -2, 0? Locus of points sounds really fancy. It really isn't. A locus of points is basically the description of a path. So, what is the equation of a path of points that are 8 units from the point -2, 0? Well, let's sketch that. If I wanted to sketch the locus of points that are 8 units from the point -2, 0, so here's my quick sketch. All right, the -2, 0 is actually about, maybe say there, that's -2, 0. And if I am 8 units away from that point, I can be 8 units in any direction. What am I creating? Well, I am actually creating a circle whose radius is 8. And what is -2, 0? Well, -2, 0 would be my center. So my center is HK, would be -2, 0. That would be the center of my circle. And being 8 units away from the point, that means that is my radius. So that means that r is going to be 8. So using my formula, x minus h quantity squared plus y minus k quantity squared is equal to r squared. Remember that your signs are always opposite. So this is going to be x minus 2, which is actually x plus 2 quantity squared. And then y minus 0 quantity squared is equal to 8 squared. So your final equation is going to be x plus 2 quantity squared. Y minus 0 is just y squared is equal to 64. And I have the equation of the circle. So don't let the vocabulary throw you. It's just another way of saying what we've been talking about. Now, what is the equation of a circle with center at the origin and the radius of r? All right, so your center at the origin makes HK what value? It would actually be 0, 0. The origin's at 0, 0. And the radius is equal to r. So what does that give you for the equation? X minus 0 quantity squared plus y minus 0 quantity squared is equal to r squared. Or x squared plus y squared equals r squared. This equation is actually the equation of a circle with a center at the origin and the radius of r. So notice here, the zeros actually cancel the rest of it out, and it's just x squared plus y squared. So if you recognize x squared plus y squared equals r squared, that is a circle with a center at the origin. So if you recognize that equation, great. So what is this really asking you? Describe fully the locus of points defined by the equation x minus 4 squared plus y plus 5 squared equals 36. They are asking you, what is this making? Well, this is the equation of a circle, isn't it? It's x minus h quantity squared plus y minus k quantity squared is equal to r squared. Well, it looks like this formula. It is. So we know this is a circle. It is a circle. And when you define a circle, you define it by its center and its radius. The center of the circle is h and k. Now watch your signs here. The center is at, well, x minus 4 means the opposite sign, so it's just going to be 4. Y plus 5 means it's the opposite sign. It's going to be -5. And the radius, well, we know this is r squared is equal to 36. So what is r? Well, take square root of both sides, and r is equal to 6. So it's a circle with a center at 4, -5, and a radius of 6. That's what this equation is telling us. You should also be able to write the equation of a circle if you are given a graph of a circle. So the formula is still the same. You just have to figure out the center of the circle, HK, and the radius of the circle. So our center, HK, and our radius are the two things we have to find. So let's see what we can find. Now the center of the circle will be where every single point is the same distance away. So if you can find your value here, you can pick this out pretty easily. Your center of your circle is going to be right there. Okay, that's my center of my circle. What's the coordinates of my center? Well, it would be at -2, 3. So HK is at -2, 3. And your radius, you can draw anywhere on the circle. It doesn't matter where. I would draw a horizontal or vertical line so that way you can count. I'm going to draw a horizontal line from here, say, to here. Whoops, helps if I draw it straight. From here to here, nice straight line. All right, I could draw it anywhere, and anywhere that I draw that radius, I can count and see what the distance is. It is 1, 2, 3, 4. So my radius is going to be 4. So now that I have my HK and I have my R, all I have to do is plug them in. Plug in H, K, and R and solve it. So it would be x minus -2 would be x plus 2. Y minus 3, quantity squared, is equal to 4 squared, which is 16. There's my equation of my circle without even having to do a lot of work. You just have to pick out the center and the radius. All right, let's try a little challenge one, see what we can come up with. Let's see if we can figure this out. What is the equation of a circle having diameter AB with coordinates A, -1, -5, and B, 3, 1? So I need to know the center and the radius of the circle. Let's see if we can figure out the center first of all. I know I have a diameter AB, and a diameter goes through the center of the circle. So let's put our diameter on here. A, -1, -5, which would be right here. There would be point A. Point B would be at 3, 1. 1, 2, 3, 1. There's point B. And if I draw in my diameter, let me do it a solid line. All right, I know that a diameter goes through the center of the circle. So if the diameter goes through the center of the circle, where does the center fall on that diameter? Well, doesn't it have to be at the middle? Yeah, let's find the middle of this line. If I count up here by my slope, 1, 2, 3, 1, 2, there's my point, 1, 2, 3, 1, 2. Aren't these two segments right here from the center, I'll call it C, to B and the center to A going to be the same distance? That makes C the midpoint. So C is the midpoint, so the center of the circle is the center of that diameter, is going to be the point HK, is actually at 1, -2. So I've got part of what I needed. Now I need to know what the length of the radius is. So I need to know either the length of AC or the length of BC. And they're the same, so it doesn't matter which one we do. All right, I'm going to draw in, I'm looking for R. This is R right here. I'm looking for the length of BC. I'm going to draw in my triangle so that I can use the Pythagorean Theorem. I know that it's going to go like this. Use the Pythagorean theorems to find the length of the radius. And that way I can count the values that I need. I'm looking for R. So from here to here, that distance is 2. That's one of my legs. And then from here down, the change in the y is actually going to be 3. So that means 2 squared plus 3 squared is equal to r squared. So what does that make r? R squared is equal to 13, so r is going to equal the square root of 13. So the equation is going to be x minus 1 quantity squared plus y minus -2 makes it plus 2 quantity squared is equal to r squared. Well, r squared is right there, is 13. So that is the equation of this circle. You need to know the center and the radius, and you can write the equation of any circle.